Hi, welcome to another video short on limits. This is in fact my example number 10, and today we will investigate limits that involve infinity. Now, don't forget, infinity is not a number, but rather a mathematical concept that we use to illustrate extreme numbers on either side of the number line. So we will be using approaches which seem logical, but you won't fully comprehend why they work until you've taken a course that deals with cardinality later on in your university career. So before we get crazy with the mathematics, the first thing you should always do is look at the value that x goes to. In this case, x goes to infinity, and substitute that into the expression. So we obtain the square root of infinity squared minus infinity plus 8 minus infinity. And we're going to be simplifying this expression. So infinity squared is in fact infinity. And we can modify infinity plus 8 is infinity. And the square root of infinity is infinity. And we finally end up with the expression infinity minus infinity. Now this is not equal to 0, but rather is an indeterminate answer, which is just a polite way of telling us that we're going to be using algebra to assist us in evaluating this limit. Now, don't forget there are other indeterminate forms to look out for so that you can use algebra besides infinity minus infinity. You have 0 over 0, or 0 times infinity, or infinity divided by infinity, 0 to the 0, or infinity to the 0, or even 1 to infinity. So let's go back to our expression. Now, when you've got a limit that involves infinities, one of the things that you will require is a quotient. Now, I don't have a quotient here, so I've got to apply a mathematical tool that will somehow give me a quotient without changing the value of the expression. Now, we've already used this tool before, and that is we multiplied by the conjugate. Now, because we see square roots minus a variable, that was a hint that maybe multiplying by the conjugate was the tool of choice. And it does two things for us here. Number one, it will get rid of the square roots in the numerator, but it will give us a denominator. And that's what we want when dealing with infinities. Because if we have a quotient, and when we simplify this quotient, if you ever get a large number in the denominator and a rather small number in the numerator, that value, that quotient, will go to 0 as the denominator gets larger and larger. And that's what we'll hope is going to happen in this expression. We'll end up with a lot of quotients where we have let's say an x in the denominator and a number in the numerator, and as x gets extremely large, that quotient goes to 0. So let's multiply our expression by its conjugate. Now, when you multiply an expression by a conjugate, don't forget in this case it's the numerator of interest. You just have to square the first term. That gets rid of the square roots, and you square the second term. Stick brackets around these beasties, and then stick a subtraction sign in between. We'll do some house cleaning, and it gives us at least a simplified expression, but it is a quotient. Now, the next tool that I would recommend to use is look at the degree. That is, look at the exponent on my x variables in either the numerator or the denominator, and try to determine which, let's say, degree is the highest in the numerator and the denominator. So if we look at the numerator, I have an x, or the exponent is 1. So I have a degree 1 in my numerator. In my denominator, I do have an x squared, but it's hidden inside the square root. So they kind of cancel each other out. So I still also have a degree 1 for my denominator. So because I'm looking for the highest degree, and both the numerator and the denominator are both a degree 1, I would like to divide the numerator by x to that degree 1. So divide by x, and same thing for my denominator. Now, I find it easier to multiply by 1 over x rather than divide by x. It's just easier for me, so I'll write it out this way. Let's give myself some more working room. Now, I'll just write it this way so that it becomes easier to see, because we want to multiply every term in my numerator by 1 over x, and the same thing, every term in my denominator by 1 over x. Now it's easy to distribute it across my numerator, but in my denominator, when I multiply 1 over x by material inside the square root, when I bring the 1 over x inside the square root, it will in fact turn into 1 squared over x squared, because when I bring something outside the square root, I end up taking the square root. So when I have to bring something inside, I have to square. So when I distribute that across, it looks something like this. Now, because we've got x's in the numerator and denominator, in both the numerator and the denominator, we can actually do some canceling out. So I'll cancel out the x's, and I obtain an easier expression to work with. Now remember, we were hoping we would obtain quotients that had constants in the numerator and variables with x's in the denominator, because as x goes to infinity, the denominator gets extremely large while the numerator remains fixed. In other words, as I look at the, let's say look at the term 8 over x in the numerator, as x goes to infinity, 8 over an extremely large number, that's going to go to 0. Likewise, in my denominator, the term 1 over x, as x goes to infinity, that term also is going to go to 0. And 8 over x squared, well, that will go to 0 even a wee bit faster. So those three terms will go to 0 once I evaluate the limit as x goes to infinity. So that allows the expression to be simplified to this. I'll do some house cleaning, and lo and behold, I obtain the answer -1/2. Hopefully this video was useful for you, and it showed you a variety of techniques and tools that were useful when dealing with infinities. Thank you for watching.